Alrighty. How's everybody doing? Waking up from lunch? All right. So today we're going to be talking about WebPageTest, specifically what WebPageTest is and the architecture we have deployed. Some neat things about it and the things that you can do and some possible use cases. And then the challenges that I faced in deploying this, deploying both WebPageTest and using SaltStack to do so. First is a little bit about me. No, clicker. This was working literally 5 seconds ago. All right, we'll fall back. So a little bit about me. I work at Rackspace. I'm into Bitcoin, cryptocurrency, things like that. Write Python. I work with the OpenStack Heat project at Rackspace. That's me and my lovely wife. And then our two animals, our dog and our cat. The Fritos, if you ever remember, there was some buzz phrase, Fritos on your something sub from Sonic or something. I saw Fritos on your cat is the new meme I'm pushing to everybody. So yeah, let's talk about what is WebPageTest. WebPageTest, so I added this slide, my note slide to me. If you want to follow along, you can find the states and example pillar data at that GitHub location, and my slides, including speaker notes, are at onitato.com. So what is WebPageTest? WebPageTest is an open source tool used to test performance of sites on various browsers and devices. It was originally written at AOL. It was open sourced in 2008. All the source code's on GitHub, so you can go and fix things that you don't like about it and all that good stuff. There's actually a nonprofit foundation set up called the WPO Foundation that actually runs the public instance at webpagetest.org. WebPageTest supports these browsers and devices, so all the usual suspects, i.e. Chrome, Firefox, Safari. So whenever you run a test, you get something like this back. So you get a nice page here. It shows up in the upper right-hand corner, you've got letter grades for some common categories of what it's testing. You get, first view and repeat views are typically what it's going to test. So, first one being no caching, the second one being after browser caches have been used. It also does some neat things, including pulling in the waterfall graphs from like the Chrome developer tools. Gives you a content breakdown, so images, CSS, JavaScript, all that good stuff. Some of the other neat things, it'll actually give you screenshots of the fully rendered page. So if you're trying to track down a rendering issue in different browsers, you could run separate tests and get these screenshots, or even actually render a full video of that page loading. You also get full API access to these results. So let's go and look at how you hit the API. So I'm going to use a tool called HTTP-IE to do this, and we're just going to come over here. And first thing I'm going to do is I'm going to list the locations available for testing on my node. So, oh no. So here's the endpoint you're going to hit, and you are going to want to make sure you add the format equals JSON, otherwise you get XML, and everybody hates XML. And so here we've got the output from the API, and it shows you the different locations that you have for testing. So here's the Virginia location using the WebPageTest driver for Internet Explorer. And it shows you how many pending tests there are, and you get a lot of data out of this. So let's also given a location, you would submit a test request. So we're gonna do that now. And so I'll just sort of walk through this real quick. We're hitting the run test.php. We're saying we're going to test onitato.com, which is my site. We're going to get our response in JSON. We're going to test in the Chicago location using the WebPageTest driver, and we're going to test using Chrome, and we're going to use the network settings for LAN. So just LAN connection speed, no customizations on that. Comes out really quick, and then you get some good information here. So the first thing, if everybody can see that, you get a JSON URL to get the test results back as JSON. You also get one of the other important things here is the user URL. This is if you were wanting to pull up WebPageTest's web interface to see the film strip and the video and all that stuff, you would get that there. If you were, say, integrating with your CI/CD pipeline, you would want something like the JSON URL. So that you could pull metrics and do summaries on, say, given this code commit, how has my performance metrics changed from the last time we ran this? So if we hit this endpoint, here it's going to tell us the test already completed because I talked too long. Otherwise, it would show you test pending, waiting X number of seconds. And you get a mess load of data back that you can look at, compare to previous tests, do metrics on, all that great stuff. It is literally a beast of a test result, and it might be longer than my scroll back. So let's head back to the presentation. And let's talk about the architecture of the private instance I've deployed. So the architecture, the design of WebPageTest consists of two main components, a PHP-based front end and a Windows agent running on Windows servers, obviously. There's a design limitation in that all of your test results and test history are stored on the PHP front end. So if you say through two of those behind a load balancer, you might be starting to see different test results show up depending on how often you refresh the page or which your load balancing algorithm is. So the suggested architecture here is going to be a single Nginx-based PHP front end, maybe behind a load balancer so that you can have a backup node, and then some manual syncing process for test results if you really cared about that. And so basically what happens is all the Windows nodes, the agent on the Windows nodes, pull the PHP front end for work or jobs that have been submitted. So let's talk about the easy parts of this. The front end was a very basic PHP stack, which is really easy to do with SaltStack, right? So it's Nginx, it's very basic for Salt. Once it's installed and configured correctly, the WebPageTest agent actually handles automatic updating of itself, including any reboots that need to be done. And then it also will install and configure the browsers for you as well if they aren't already installed. So if you configure it to use Chrome and Firefox, it'll reach out, grab an installer, and automatically install it for you. You don't have to automate any of that. It does it for you. That was really great. So to deploy this stuff, I use SaltCloud for OpenStack on Rackspace. And for those who aren't familiar, SaltCloud consists of, at least in my configuration, three main components. We've got providers, profiles, and map files. So let's talk about the provider configuration first. Let me get my pointer. So here we've got the ID of this provider, my Rackspace config. You might want to separate these with say like a dash region code, like say IAD or ORD or whatnot. You set your menu config so that you tell it where to go for the master. I recommend a DNS name here so you can change that later, or if you lose a host, you can bring it back up. Some just where to go for identity tokens, the compute name, all this other great stuff. And then you're going to set a user, a tenant, and an API key, and also specify your region. Profiles are just ways to describe common pieces of your architecture, specifically what size server to deploy and what image to use to do that. So here I've got my WebPageTest Linux box is going to be on that same provider config we just talked about. It's going to be a 2 gig box, and it's going to run Ubuntu 14.04. My Windows profile has a bit more in it. The typical size and image, this is Windows Server 2012 R2. With Salt Cloud and Windows, you have to provide the minion executable to be installed from the actual Salt master. So I just pull this off of Salt's download page and host it on this local Salt master. We also have to, I'll come back to the bootstrap here in a second. For WebPageTest purposes, I'm setting a couple of static grains that include this particular profile's location, the label to be used in WebPageTest, what group it belongs to, and the browsers it should be supporting. We'll get into how that location data matters here in a bit, but let's take a closer look at this bootstrap file. So by default, Salt Cloud reaches out over port 445 over SMB using WinExe to auto log into the box and bootstrap the actual Salt minion, accept the key and all that great stuff. Unfortunately, on the stock images, that's not open. So the file that we're bootstrapping onto these boxes contains this command here that opens the firewall on port 445 to allow the Salt bootstrap processes to happen. Something you don't want to leave open. So part of the automation, I use this PowerShell here to go back and close that port. And I'll reach into this a lot more here in a minute. And then here's the map file, very simple. So you say what profile you want and then what the host names of the nodes you want to are. And then you just feed this into the Salt Cloud command. It reaches out into your infrastructure and does name matching and does intelligence on, hey, do all these exist, yes or no? Which ones do I need to build? Which ones are already there? I don't have to worry about that good stuff. So yeah, let's look at the pillar data that I'm using for WebPageTest. So I've got one big dictionary called WebPageTest, and we start out with some configurations here. So the site name is the Apache name that we're going to use for virtual hosting, or Nginx. This is the URL, which is, I cut it off here, but it's the URL to get the zip file, and the SHA-256 hash of that zip file. So I know I've got the right file, and so that I know the download was completed all the way. I have a little toggle here where I can switch between Apache or Nginx and then PHP5 or PHP FPM. Here I've got some Windows-specific settings. So this is the user that WebPageTest will run as. This is the password it will use, the installer, tempter, and then the actual name of the zip file as well. The packages section here are dependencies for the PHP app. So these are like Python module, not Python, PHP modules that need to be installed so that the interface works correctly. The bottom half of the pillar file looks like this. So we've got some PHP variables that we need to tune, set the location of the FPM socket, some more settings related to WebPageTest, including the title of the page. This one here, max runs, contains or defines the max number of tests that will run against a single website and a single test request. So you can test anywhere from once to 9 times. You're reloading that site over and over again to see if the metrics change. We've got allow private, so allow private testing to be done, setting that as 0. The key that it uses to reach out and grab work, so the agents are configured with this key so they can reach in and grab work off the PHP nodes. And then here I've got a dictionary that contains a list of test locations. So on Pillar, you define all possible test locations that WebPageTest can test from. So that would be like Chicago, Virginia, Hong Kong, Sydney, etc. And you would define this series of values for each one in a list. The default one being which one shows up as default whenever you first load up the interface. So the basic component here is essentially, this is how we're doing PowerShell states. Your ID that is descriptive and tells you what this PowerShell is supposed to be doing. The module you're going to run is command.script. So the module is command, the script is your function. You pull your PowerShell script itself off of the master. You specify PowerShell as the shell type. And then I'm also using stateful equals true here. What that means is at the end of my PowerShell, whenever it's done doing whatever it's supposed to be doing, I'm going to write output that follows this pattern here and says changed yes or no. So did something actually get changed from the box? And then a comment on what that change was or wasn't. This allows the PowerShell to be this sets idempotency so that it isn't trying to do the same thing over and over and over and over again. It doesn't run it unless it has to. So this particular one for closing 445, we're just reaching into net firewall rules and looking for anything that says Salt Bootstrap, and we get that as our current value. Then we say if this is actually enabled, we're going to disable that rule because we don't want anybody else to be able to reach in and hammer our box with passwords over and over and over again. And if we do disable that, something changed, and we're going to tell them, well, we disabled port 445. If it's already been disabled, it's going to tell us that. So pretty straightforward. So let's talk about some of the challenges with WebPageTest. Location configuration is overly complex. There is an issue with Zen and the dummy net driver that does traffic shaping. Automation on Windows as a whole has been a challenge. And mobile devices were, in our particular use case, a challenge. And then also looking at an ampersand bug that I ran across, which was really annoying. So this is the actual documentation on WebPageTest's site that tells you how to configure locations. There's lots of boxes and lots of arrows, and I was very confused. But it boils down to this. The idea is that you define all locations that can possibly take work on the PHP front end, and then you spin up a Windows server on the back end to do the matching to that. So you match, and so essentially I've abstracted this into grains and pillars, which looks like this. So in pillar, that list that we talked about earlier, I define this group right here for each location that should be possible to be tested from this box. And then I match that pillar location to the grain location over here, so location, label, group, browsers, to the grain data that I'm defining in my Salt Cloud profiles. My states, essentially, for the front end, look at this listing of locations and do a for loop in Jinja to write out all those locations. And then on the Windows side, it reaches into its grains and writes out that configuration file using the grain data. So it's something that you kind of have to manually keep in sync, but as long as they're defined and they are identical for the locations that you want to do, this works out really great. So I talked briefly about the dummy net driver. Dummy net driver is a driver that sits in your network stack on a Windows machine. And it sits between WebPageTest and the actual network and does basically traffic shaping. So you can do things like, what would my site look like if it was loading on, a 3G connection with 20% packet loss, something like that. Unfortunately, the Zen hypervisor fights with this module and doesn't let it load fully, so you can't actually do any of the traffic shaping. I was able to actually get it to install. Uppsala University, there's someone there who wrote a utility called mindinst.exe, which lets you essentially install those network bindings without any kind of manual operation. So the typical way that you do that install is you right-click on the network interfaces icon, you go into the network bindings, you install one, you choose a source location for that. All very manual clicky things, and there wasn't anything in the registry or PowerShell directly that lets you do that in an automated fashion. This guy had the same problem. He wrote a utility that does it, and it works really well, except that we run Zen on our cloud, so our public cloud, so it's not too happy with that. WebPageTest.org is actually run on Amazon, and they have the same issue here. They can't do the traffic shaping either. So let's go through some of the Windows automations that you don't typically have to do with any server. So auto log on. So in order to do all that fancy video capture and film strips and all screenshots and all that other stuff, you have to have a user logged in so that it can do that screen capture. So typically in Windows, when you do an auto login, you pull up this GUI here and you type in your credentials and you're off to the races, right? It's really quick and easy. Excuse me. On the PowerShell side, you have to reach into the registry. So I set a couple of login paths here. I pulled the domain name, which is the local host name, off of grains, and then I pulled the Windows variables that we talked about earlier out of pillar. And so again, kind of the same if-else structure here that we saw earlier with the port closing. I am getting an item property of whether or not auto admin login is already enabled. If it is enabled, I'm going to check the values for the default username and the default password. So basically, are the credentials that are in Pillar, do those match what are in the registry? So I can actually update the credentials in Pillar, have that roll out, and have that auto login properly. If they match, if they don't match, then we're going to set those to what they should be, and we're going to write out our stateful again. Changed equals yes, credentials have been updated. If they do match, then hey, you know, we've already tested to make sure that was enabled, and we've also said, okay, yeah, auto login's enabled. We didn't have to change any of the credentials. Nothing changed. We're good. We're happy. Then the else off of whether or not it's enabled is going to set all these properties in the registry so that the next time that server reboots, it will auto log in as a WebPageTest user. Another one that you have to do is, you know, you don't want the screensaver to pop on in the middle of a screen capture, right? Otherwise, you're going to be getting the Windows screensaver as opposed to what you actually care about. Really easy to do in the UI, and somewhat less complicated than auto login. So again, I'm setting a path here to look in the registry. We're going to so this particular path and key may not exist already. So in this case, instead of an if, I'm using a try so that I can catch the exceptions and do something intelligent based on that. So I'm getting out this particular value, and I'm writing it out for debugging purposes. And then if it fails to get that value because it doesn't exist, I'm just going to set current value to false because I know it isn't there. And then so if current value is not equal to 0, meaning so screensaver active is set to 0, means screensaver isn't active. If it isn't active, if it isn't set to not active, I'm setting that property to 0 so that it disables the screensaver and writing out my stateful output for Salt. One more, we've got the shutdown tracker. So I told you earlier that WebPageTest agent actually reboots itself automatically whenever it updates itself and needs to reboot. Well, you don't want it to hang on that reboot asking why it's rebooting. So they recommend that you disable this. So we, again, set a path. We get our current value. And we basically do the same thing. We check and see if that's already enabled or if that key even exists. We do intelligence based on that and write out our stateful output for that. So this, unfortunately, is the only manual process in the entire WebPageTest deployment. Once you run your states and you get auto login set up and working, you have it reboot, it auto logs in for you. Chrome and Firefox will work just fine for you. Internet Explorer, however, requires one additional browser helper object that has to be authorized to run by the current user. I've dug in the registry, I've dug through PowerShell. There is a location in the registry where the current authorized browser helper objects are listed, but they're in some kind of weird hash format that I can't decipher. So adding those manually just doesn't work. So you have to actually pull it up, open Internet Explorer, say, you know, yay, welcome to Internet Explorer. Then you look for this little yellow bar at the bottom, click enable, and then close it and you're done. So I mentioned mobile devices. You can test using mobile devices, Android phones and tablets. The only gotcha is that you have to have them plugged in directly via USB to the host. So on a cloud environment, you can't really do that. But if you have like an actual hardware box somewhere that you're running as an agent as, this would be more than doable. You just plug them straight in via USB. The agent should pick up on them and let you test with them, assuming you have the browser configured in your locations. And this would also be a good idea for, like, you know, if you wanted to do the dummy net stuff, this takes Zen out of the picture, so you can do that as well. So let's talk a quick bit about the ampersand bug. This character gave me a lot of grief over an entire day. Anybody care to guess how? Maybe. What? So the question was, put something in the background. No, unfortunately not. Let me show you the logs. Give you any hint? Yeah, you got it. So it passes the secret key, which my resolution is screwed with my output here, but it passes the secret key as a PHP GET request, and having an ampersand in that cuts that value and makes your key invalid. You know, it's like, what? Why are you doing that? So I randomly generate my passwords and keys that I use everywhere, right? And so it got an ampersand in there, and I spent like an entire day on their forums and all that trying to figure out why. And yeah, the key. Yeah, exactly. So that was a lot of fun. So let's talk about the issues I had with SaltStack during this. Salt Cloud has shaky Windows support. It's actually gotten a lot better. So the first one you see here is the PR 14748. I actually authored this PR. What was happening was with the OpenStack provider, it wasn't using the password for the administrator account from the API. Whenever it went to go and try to log in, it was using what was statically defined in the Salt Cloud configuration, which if you're booting a new server, you don't have that password to define in Salt Cloud until you boot the server, chicken and egg. So I went ahead and authored that, and it recently got backported to 2014.7. So this should be fixed, and you shouldn't have any problem with that. Issue 14593, the fingerprint mismatch. Currently, if you use a map file with Salt Cloud to deploy a series of Windows servers, for some reason doing it with the map file mangles the fingerprint that gets put on the Windows box, so it never can authenticate properly to the master. It thinks the master isn't who it is. They're still working on that. I don't really know how long it's going to take, but they're really responsive. The fingerprint issue brought up kind of a larger discussion on 15984 on what are we going to do to replace WinExe, because it's not many distros package it anymore. You have to go to some weird SUSE site to pull it off and put it on your master. If you want a deb file, if you want to compile it manually, have a good week doing that. It's a nightmare. So yeah, I mean that was kind of challenging, and that was kind of annoying. The other thing was we need more Windows state modules. So looking at this is the code breakdown in my GitHub repo showing more than half of the code I had to write for this project was PowerShell. And the other half was salt states, misidentified here as scheme for some reason. We would really benefit from a Windows registry state that said, given this key in the registry, make sure it has this value. That would go. That would probably cut 80% of the code out of this. So I think we have like a hackathon or something tonight. Maybe we can all get together and do that. That'd be fun. And then obviously the other challenge was learning PowerShell, which actually wasn't that bad. It was a positive experience. It's really well documented. It's readable, and it reminds me of a nicer Bash almost. It kind of helped that I have 3 rockstar PowerShell devs that sit behind me at work, so that kind of helped. But that's what it was. So try WebPageTest. Give it a shot. There's a public instance at webpagetest.org. You can use my salt states to spin up your own private instance and do testing with that. We also have, so I work with the Heat team at Rackspace, and we have a Heat template that will deploy a single Windows server with WebPageTest already installed and configured and ready to go. You have to go in and do that browser helper object enable bit like we talked about, but it gets you 99% of the way there. We also have a Saltmaster template too, so if y'all need one of those, it should be good. So yeah, that's pretty much it. So yeah, like he said, submit feedback on the mobile app. My slides with speaker notes are at onitato.com. States and PowerShell are at github.com/lunaturk/webpagetest. Yeah. So we can kind of bounce out of the slides here, or we can answer questions. Go ahead. So the question was, how are we using WebPageTest itself? Is that right? Yeah. Okay. So the idea is that given changes to customers' code or application, we would be able to use this internally, say from a support perspective, to say, okay, you're having your site's loading slow, and that's a very big ambiguous problem. This gives us a concise and repeatable way to put metrics around slow, so that we can point to specific things. So in the waterfall graph that it generates, you could say, hey, look, you've got all these dependencies on this Facebook API that's taking 400 milliseconds to respond. It's not Rackspace. It's your connection to Facebook or whatever that may be, right? So whatever third-party tool or API you're trying to hit or pull in. The other piece would be like, say, integration in a CI/CD platform where you could pull metrics in based on pull requests and say, okay, this PR actually, increased our performance and made us faster by 50%. We're definitely going to merge this. Or the converse, where this pull request is like, oh, you totally tanked out our performance, and our site takes 5 seconds to load now. We're not going to merge this until we get that fixed. That kind of thing. Yes. So are you asking the PowerShell, having to write all the PowerShell? Is that the problem? Or? Mm-hmm. State, yeah. So the question is, what's the biggest shortcoming in writing all the PowerShell myself versus having an actual proper state to do it? The biggest downside is that giant mass of PowerShell that I have to support now, right? And it also, it'd be easier, and it'd also be a lot less duplicate code to have, like, say, a registry state where I could provide it, the path and the keys I wanted to set or enforce that configuration at, and that the code to do that intelligently would live in the actual Salt execution and state module, so I don't have to have that same code repeated over and over and over again for each script I'm trying to run. I could throw this all in one big monolithic script and reuse that function, I guess. But at the same time, I don't really want to do that, because that means if something breaks in that big monolithic script, it makes reporting on that really hard with the stateful out of the states, and it makes debugging that a lot more difficult. Yes, so in the end, I did manage to put all the functionality I wanted, except for the browser helper object, which is a limitation on the PowerShell/Windows side more so than anything else. Yes.
Are all the Windows instances that you've set up internally only internally available, or can you expose those to the public WebPageTest?
So the ones that we run internally are internally available, but the public instance that the WebPageTest organization runs at webpagetest.org, you can do all the same things, and in fact, they've got a lot more test locations than what we have, and they actually have some mobile device support as well. So they've got people actually running hardware with USB devices plugged in. So all you really have to do to hit the API on the webpagetest.org one is request an API key, and then you just pass it along with your requests, and it works just the same as I demoed.
I'm curious if you've run into, in that realm, discussions about managing security vulnerabilities. So for example, if you offered up some of your Windows nodes to the public cluster, how do you segment that off so it doesn't affect your network?
Yeah. So the question being security implications of exposing our Windows worker nodes to the public. I don't think we'd ever actually expose the nodes directly. We would probably just expose the PHP front end so that we wouldn't have to deal with that piece necessarily. But you have things like, okay, so test history for the WebPageTest instance is publicly available, right? So you can see who's been running tests and for what sites. So you'd have a problem there of, say, like if you were running tests for customers who didn't want to necessarily know they were hosted at Rackspace, or you didn't want some customers to know other customers were hosted. It's more of that kind of problem, more so than, I mean, because like if you're testing a website, like it's probably publicly available on the internet, right? So there's not much there that people are going to be able to want to protect. But that whole like customer information bleed is probably the biggest concern. Any other questions? Do y'all want to see more states or something? So here's the Git repo.
Would you, having worked with this, would you envision that the things you wrote in PowerShell, if you wanted to make them an execution module, would you still keep them in PowerShell, or would you use like command line?
So the question being, given that I've worked with this, how do I envision an execution and state module looking, essentially? So I've actually had some conversations about that with some people. There's a Python library called, it's like Windows Registry or something like that, that actually will dig into the registry. But that's yet another thing to pip install in a Windows node. So it's kind of a toss-up in my mind currently between just shelling out to PowerShell and getting that stuff back into Python and keeping it pure Python so that you don't have that additional dependency, or trying to figure out how to import or get that library onto the Windows node for Python to use to then write your execution module. Yes?
Do you ever like rely on return codes from command loops instead of writing stateful scripts or anything like that? Like one-off commands?
Yeah. So the question being, did I ever rely on the exit codes from commandlets as opposed to the stateful stuff that I set up? With the exception of maybe the catch statements and the PowerShell, like not really. I was like, obviously if they bombed out, then they bombed out and would throw an error. But I didn't think to do just a single command line that would do that. That's an interesting idea. That's pretty interesting. The comment being they haven't found return codes reliable for command in the command module, and I don't know. Yeah. Here's the slides, and here's my site linking to the slides and all that good stuff. The slides themselves. So this is what you'll get whenever you go download them. This is. So actually I can show you a demo a little bit more on the actual test results here. So you can see like the nice waterfall graph, all that great stuff. But like just to give you an idea, let's look at the details tab. Details on this test show you the really nice waterfall graph and what took the longest and all that great stuff. Just tons of information that you could look at here. What's even better? There's one here, performance review. There's one that's huge and takes forever to scroll down, and I'm trying to find that one. Yeah, this might be it. No, of course not. Anyway, pretty graphs, blah, blah, blah. Screenshots, and then you can also, you can have it send a job to create a video, and then it'll actually show you the site loading. So this is how long it took for my site to load. And it took 3.4 seconds. So really cool. This is the location documentation I was telling you all about. Really, like they do the best they can in explaining it, but it's a very overly complex setup. And then, so pillar, profiles, and then here are the issues I mentioned. Okay, yeah. Any other questions? Cool. So the question being, is there a security setting that it stopped me from enabling the browser helper object? Not that I could find. I Google searched and I asked, we've got a lot of good Windows admins, that one of them that actually helped me find the networking stack tool that let me install that automatically. And we couldn't come up with a good solution for it. It was just, other than maybe trying to script out a graphical click thing, but that would have been horrible. and unreliable.